Good evening, everyone. I'm Dr. Pratibha Jadhav, and I warmly welcome you all to the fourth session of the Parivartan Webinar Series brought to you by Plastindia International University, Vapi. This series is our initiative to bring together thought leaders and innovators in plastics and polymer engineering, artificial intelligence, and sustainability, fostering dialogue on the pressing challenges and emerging opportunities in these fields. Today's session opens the door to a lesser known but the vital aspect of polymer science, how testing exposes their true behavior and performance. Before getting into the main session, it is my pleasure to invite Dr. Prashant Gupta, Senior Assistant Professor, School of Engineering, PIU, to share a few words about the university and its vision. Over to you, Dr. Gupta.
Yeah, thank you. We'll take you through what the university is all about in this presentation. Plastindia International University has been founded by Plastindia Foundation. So it's a non-profit organization which is founded by the plastic industry for the plastic industry. So as you can see in front of your screen, Plastindia Foundation had come up rather in 84 due to all the major plastic bodies coming together and thinking about how do we take plastics, the field of plastics forward in our country, and that is how Plastindia Foundation came into existence. And we are a CSR part of Plastindia Foundation, where Plastindia Foundation is sort of giving back to the society. So we have been found by the industry conglomerates altogether, and again, our role is to dedicate ourselves to the plastic industry. So the vision, the holistic vision of the university is to develop a world-class university in plastics technology, research, and innovation. And as a part of this process, what we want to do is we want to help the generation which is coming up and which is going to drive the industry forward. And along with those, we want to help the industry as well. We have an academic partnership with UMass Lowell USA. So UMass Lowell USA has been teaching plastics since the last more than 70 years now, rather. And Plastindia Foundation, through Plastindia International University, has brought together both of them, UMass Lowell and Plastindia International University, so that state-of-the-art facilities can be made accessible to the aspirants who want to learn polymers and plastics. So we'll just look at what this partnership is all about. This is about designing of the curriculum, that is the syllabus and modules in plastic engineering. So the curriculum that we cover as a part of BTech in Plastic and Polymer Engineering and BTech in Computer Science and Engineering is the curriculum which is taught at UMass Lowell. So we take their subjects and we teach. So it's a global curriculum that is basically taught in India. Student and faculty exchange for research-based activities, lectures, and discussions. So, student from here going there, faculty from there coming here, from here going there again. So, these student and faculty exchange programs. Then, applied research and community-based projects. Opportunities for engaging students and researchers for establishing peer relationships and mentoring. Just a minute, yeah. And mentoring opportunities. Faculty develop. So faculties will be sent from here to UMass Lowell for their training. Then conducting webinar series. So this is the second of the series that we are running. We have already done one with UML. So it's a global institute in plastics technology with a 70-year-old presence in plastic and polymer courses. Now, next question is why should one think about PIU? So there is an exclusive focus on plastics and polymer engineering. So there are a few private and government institutes which are into plastics, but then they just offer it as a course. And when we're talking about the university just focusing on polymers, it's altogether a different preposition. So just an example, the computer science that we cover is inclined towards robotics, smart manufacturing, industry 4.0. So we are trying to inculcate or bring in the expertise of AI, ML, data analytics, machine learning into how it can, help polymer area. Then we are very proud on delivering industry-driven education. So the panel that we have as a part of the governing body, the panel that we have as a part of meticulously creating or drafting the syllabus consists of stalwarts in the industry. So the syllabus that we cover is not what is the demand today. We're thinking of what is the demand, what demand is going to be there tomorrow. There is a strong industry integration and hands-on learning. We guarantee placements, so we offer 100% guarantee on placements, or else the fees will be returned. There are scholarships and financial aid. So as we are a UGC and a AICT, recognized institute, we offer industry-based private scholarships and government scholarships are always open because of the approvals of AICT and UGC. It's a gateway to global education and excellence. So student can think of graduating from here and then it becomes a ladder towards getting into UMass Law for a master's or a PhD program. Or as a part of the BTech program, we can enroll students into global immersion or a cultural exchange program. We can send the student from PIU to UML for a certain period of time. So next is scholarships and placements. So we look at all four categories of scholarships that I just briefed you about. First is the merit-based scholarships. So students having good marks, so on the basis of their merit percentages, we offer scholarship. Then there is need-based financial aid. So if a student is not from a healthy financial background, we help those students. Industry-sponsored education, which is our private scholarships that we offer, irrespective of whether the student, is so it has to. So this happens only when the student is not having any other scholarship, and then there are government scholarships for category based, admissions. There is a return on investment which is very high. Again, so we are talking about a fees of 75,000 rupees. So 4 years, it is 75,000 rupees is 3 lakh rupees, and the promise that we provide is of a package of roughly 5 to 6 lakhs, which is again slated to grow as the years pass by. When you are investing just 3 lakh rupees, the output is just double in the first year itself. And we offer guaranteed placements that I already told you about. The only condition that we put is the student should secure a 6.5 CGPA and above. And the basic need of keeping that is also towards, the student should be able to target industries which pay high, right? And they have a barrier of 6.5 or 7 CGPA barrier. So this is our global faculty, industry experts and mentors. So we have a good team. So on the left side, you can see all the UMass faculties. You have Professor Chen, Professor Kazmar, we have Professor Driscoll, Professor Ameli. So these are the faculties who have already covered the first series of our webinars that we conducted. And on the right, you can see industry experts, Shri Vinod Kumar and Shri Sanjay Saab. These are stalwarts again from the industry, years and years of experience in the polymer industry. A few experts with respect to AI, ML, cyber security as well. This is our team, Professor Patil, who is the Dean from School of Engineering. Dr. Chatterjee, he is an Associate Professor in Plastics and Polymer Engineering. I'm a Senior Assistant Professor. Then we have Dr. Jadhav. She is hosting the event, an Assistant Professor in the Department of Physics. Dr. Sharma, who is taking care of the Department of Chemistry, Mr. Praharsh Patel. So he is pursuing his final year into his PhD from Pandit Deen Dayal Petroleum University. He is taking care of the Department of Mathematics. We have a few visiting faculties who are again doctorates. So the stand that PIU takes is that we don't hire anything below IITs or NITs. Premier institutes only. We don't mind in investing in resources which give us more depth in terms of experience and imparting education as well. The courses offered at two, which is BTech in Plastics and Polymer Engineering, where we have two entries in this current year, 2025-26. We have a regular first year entry and a direct second year entry, which is for diploma to degree students. So a student who has done 3 years of diploma, he can directly end up into the second year of the course. And we have BTech in Computer Science and Engineering, which is for the current year, we are only taking first year admissions. These are few companies who have already signed MOUs with us uh, in the current year with respect to, helping the students in terms of holistic education and their placement and in-plant training opportunities as well. So the tuition fees that stands today is 75,000. It is subject to change. There is a FRC body of the government of Gujarat, that is the fees regulatory committee. They take care of increase or decrease of the fees, and they might change it by 10% this year. But as we stand today, the fees stands at 75,000 rupees, and there is a refundable deposit of 12,500 rupees as shown in front of you. We have a 50% quota from Gujarat, that is ACPC Admission Committee for Professional Courses, and an All India quota of 30 seats. This is regarding the 60 seats that we have in any course. The eligibility is pretty simple. The student should have 10 plus 2 with a 45% score in physics, chemistry, and mathematics. If the student is a vocational subject, chemistry can be subbed out. And if the candidate belongs to any category, it can be 40% of theory and practical marks. And either of the exams, that is GUJCAT as we call it in Gujarat, or JEE Mail, which is for all India candidates, can work. If the student is coming from a diploma background, the student should have passed diploma with a 45% score, and again 40% in case of reserve category in the final year of the course, or as per the awarding of the diploma that the college provides. This is the current campus that we are having. So I am sitting right now in this building. This building hosts our first and second year students of plastic and polymer engineering and computer science and engineering. As you can see, there is a bullet train very near to our vicinity, right? So these are some of the pictures just to make you aware, sitting virtually at your houses and your offices. This is our main gate. This is the building that I was talking about where I'm sitting. I'm sitting on the first floor in this. So this is our School of Engineering building. This is our engineering chemistry lab. Another snapshot from a different angle. You can see the students working. The first year students who have who are recently doing the engineering chemistry program. Then this is the physics laboratory, a computer lab with a full seating of 60. This is all air conditioned, centralized. Another angle of it, this is the engineering graphics laboratory for first year drafting courses. Design thinking laboratory. So we have exposed our students to a subject called as design thinking and innovation, which is very important from a business perspective. I mean, talking about any challenge that you want to solve. So we have two 3D printers where we have exposed them in both the semesters. This is our engineering workshop and processing labs. So you can see the machine. We already have a CNC machine, a couple of injection molding, and a blown film extrusion plant. Professional communication laboratory. So this takes care of the language. We tutor our students in both first and second semester with theory and practicals. Theory covering the writing and the writing aspect, and then we are talking about practicals which are helping out with listening and speaking aspects. Purchase two softwares for this. This is an institutional library with reading room. This is our classroom. Again, centralized air conditioning is available in the classroom. Our cafeteria. These are a couple of rooms which are boys common rooms. Boys and girls both are separate, and we have some recreational facilities in terms of sports like carom, table tennis, chess, and these things. This is our master plan for phase 2 and 3 as we grow. We'll have an MBA kind of an executive management institute. We'll have an institute by the name of School of Sustainability. We're going to have an institute by the name of School of Continuing Education, and an auditorium is there in the plan as well. So thank you for your time. Without taking much, I'll pass on the session back to Dr. Jadhav.
Thank you, Dr. Gupta, for the insightful and inspiring words about PIU's mission and vision. Now, let's proceed to introduce our speaker for today. We are honored to welcome Dr. Harindu Vyas. Dr. Vyas is seasoned polymer technologist with over 20 years of experience spanning academic research, industrial consultancy, and leadership roles in the plastics and polymer sector. He holds a PhD in applied chemistry from MS University of Vadodara with a research focus on the synthesis and characterization of ionomers as a compatibilizer for polymer blends. Dr. Vyas is a founder and principal scientist at the Global Plastics and Materials Laboratory in Vadodara and is also the director at CNM Nanotechnologies Private Limited. His previous roles include tenure as an assistant director at the Gujarat Industrial Research and Development Agency and president at Signet Industries Limited. He has also contributed as a lecturer and R&D specialist across various institutions and organizations. Dr. Vyas is actively involved with the professional bodies, currently serving as the honorary secretary and a governing council member of the Indian Plastic Institute, Vadodara. He has also served as an advisor and committee member for various national and international organizations in the field of plastic technology. With a strong research background, Dr. Vyas has authored 17 publications in reputed journals and conferences and holds an Indian patent for the development of ionic graft compatibilizer for enhancing visibility in polymer blends. His passion lies in bridging the gap between fundamental research and industrial innovations in the evolving field of polymer science. Dr. Vyas will demonstrate how behind the scene testing brings polymers to life, exposing their secrets and enabling smarter material designs. Be- Before we start, I request all the participants, if you have any questions, please put it in the question and answer box during the session. Dr. Vyas, we are delighted to have you. Please take a session forward. Over to you, Dr. Vyas.
Thank you for your kind words. And thank you, Dr. Prashant, for showing such a beautiful university that is PIU. And it is a need of today's industry requirement. Because as plastics is being propagated, we require such kind of education institute. So I will just share, just to give brief, Dr. Jadhav has told, I'm a person of a testing person. Today I'm going to speak on the subject called testing. Many lectures have been heard on the different variables, new topics of plastic, but I will be focusing more on testings because it is a very important part of the production area. So we all know polymers. We all know this is a very simple word, a polymer. It is say large molecules which are being made by different monomer units due to polymerization. So I will just give a fast and brief that what polymers are classified. Polymers are classified majorly basing on three things. One, the source, whether it is natural or synthetic, that is man-made, the structure, and the properties. So the source, suppose, for example, we think the natural polymers, means they are available from plants or animals, organisms. Various examples we all know, plants, cellulose, starch, animals, we all know silk, wool, and even microorganisms, that is alginate and polyhydroxonate. Applications of natural polymers are in packaging industry, drug delivery system, biomaterials, textiles. So these are the classified as a natural polymers. Now comes on the synthetic polymer. Synthetic polymer is also known as man-made polymer because it has been derived from petrochemicals. They are diversely grouped because of numerous applications in different industries. We all have this examples known: nylon, polyethylene, polyester, Teflon, epoxy, and so on. All are synthetic polymers. And it has got wide applications starting from plastic parts, fibers, building materials, adhesives, defense, aerospace, etc. So the second important classification how that polymer is classified are on the basis of structure. There are basically three types of structures for polymers. The first is called the linear polymer. Linear polymer is very simple, where the monomers are joined with end to end in a straight line. They have only two end groups. And they are very flexible and highly compactly packed. The key features of this linear polymers are simple structure, only two end groups, highly flexible, and closely packed, because of strong interchange interaction. The properties are linear polymers are generally rigid and can be thermoplastic. That is, they can be softened on heating and shaped of the desired shape. Linear polymer exhibits high tensile strength or high strength, high viscosity due to long chain and structure. Applications are basically packaging, medical, coating, constructions. So the second classified polymer is the branched one. Branch structure polymer is a type of polymer with two side chains or branch extended from the one backbone chain, unlike the linear one. Linear is a straight polymer and branch has got multiple branches coming from the backbone. So what are the key features of branch polymers? Since it has got many side chains, branch polymers come out with different sites for where it can be, say, reacted with other polymers. Since it is a branch, it is a very complex structure, and there are different types of branches, say, star-shaped branches, dendrite branches, or comb-shaped branches. The properties of branch, as we know, that is a branch, it is bulky polymer. So definitely it will have low density, low strength, low melting point, low boiling point compared to the linear one. Branch polymer has increased solubility in different solvents because due to branching, they cannot be entangled in between other branches. This way, it lowers the viscosity. It has got very advantages on different applications. Branch polymers have high terminal groups, high chemical reactivity, as I told, because there are many reactive points at the end of the branches. Basically, branch polymer finds it wide application in drug delivery. It can be used as a rheology modifier to increase or decrease the rheological properties. It can be used in polymer band as a compatibilizer by adding other chemically active chemicals at the ends of the branches. Now, the third structure on which the polymer is classified is cross-linked structure. Cross-linked such structure, as the name suggests, it is a mix of multiple linear chains of polymers that are interconnected with each other through a very strong, say, covalent bond. And this way, a three-dimensional structure is formed, which is called a cross-linked structure polymer. So the key features of this cross-linked polymers, as it is cross-linked, it is three-dimensional, it is but obvious because from all the three sides, it can be, say, covalently bonded with different linear polymer chain. It has got covalent bond. Covalent bond in cross-linked polymer is strong and create a permanent connection between the polymers, making it a very strong and, say, it is very difficult to dissolve in solvent. It has got high rigidity because it has got three dimension interconnected structure. So the properties of cross-linked polymer have, again, it has got high strength, high dimensional stability, thermal stability also more, chemical resistance is excellent. Because since it is a cross-linked polymer, it has got a very good barrier properties for gases and liquids. Some cross-linked polymers are also be used for swelling purpose, good swelling properties, and hydrogels is one of the good example. There are some self-healing polymers right now, they are into a market, they are into demand of self-healing properties. Finally, the applications of cross-linked polymer are in electrical, automotive, mining, and chemical, where we required a strong, rigid, highly chemically and thermally stable resistant material. Now, the third way on which the polymer is classified is by the properties. This everybody would be knowing. Thermoplastic is the material which is softened by heating, can be made into any shapes or molded into any shape, and again it cooled, it formed that shape without changing their chemical composition. All the general purpose plastic majorly are thermoplastics. It includes polyethylene, polypropylene, nylon, PC, PET, ABS, whatever you say, it is polymer, thermoplastic. It has got wide applications in the areas of packaging, goods, automobiles, textile, food industry. The second properties thermal of the polymer is thermoset. As the name suggests, once a polymer is set, it won't be able to form or we cannot reshape into another shape or size. So it has got a permanently undergone irreversible chemical reaction and form a strong three-dimensional structure. Normally, all the examples which we include are, say, UP, we know polyesters, epoxy, phenol formaldehyde, urea formaldehyde, melamines, all are thermosets. And it has got wide application in the field of automobiles and electronics, as well as construction. And the third property of polymer in which it is classified is elastomers. Elastomers are a type of polymer that have got high elasticity, that can be stretched and come back to its original shape. That is a definition. It looks like a rubber. Very nice, very truly said. But it's a polymerized with highly elastic nature. The examples are polyurethane, silicone rubber, natural rubber, thermoplastic elastomers, TP, and it's got applications like in tires, seal, gasket, footwear, and etc. So what testing reveals? Why it is important to have testing? We all know that testing is the benchmark to evaluate our product, our plastic, our reaction or our resin. So today, I would be just giving a brief and important knowledge, which is everybody should know on testings. What are the initial parts of testings? And then in the last, there will be an excellent case study for a testing method. So testing is a procedure for identification, measurement, and evaluation of one or more qualities, characteristics, or properties of material product that produces a test result. We get a test result or a test report which provides all the details of that particular sample that we have tested. So the fundamental aspects of testing is very simple. First, to ensure what the raw material which we are purchasing are acceptable and are consistent quality or not. Because initially, when the raw material is entering into our plant, our factory, then the testing comes into the picture from day one. If we have this practice to test the incoming raw material, then half of the issue of the quality of product is nullified. So incoming raw material are acceptable and consistent and good quality is ensured by testing. Product of intermediate stages of manufacture are also acceptable in quality, because stage-wise, in first stage, if we have a compounding unit or if we have a, say, multi-layer packaging industry, we are running an industry, we will have a raw material testing. Then we will have produce a film, then we will have film testing. Same way, that is the intermediate stage where we can ensure our quality, our product by testing. And finally, the end product of overall product. Yes, final product should always be tested and should be at the acceptable quality. So now, as we are moving towards India is heading for means highly developed nations and competing different companies like countries like China, America, Germany. We have to be very thorough, very sure with our quality of the product. And that is only possible by having testing on the priority. So other fundamental aspect of testing is to evaluate. What evaluate? We can evaluate that of the products, or we can evaluate our competitive competitive material. And according to that, we can modify or upgrade our own product, our own process. So, and the fourth one is we obtained an evidence that changes has taken place in the process. Whatever changes we have done, whether it is in raw material section, whether it is in process, it is affecting the product or not, final product or not, is confirmed by testing only. And finally, it proves the quality and the safety of our product. So types of testing. Everybody in the plastic industry or in the academia, students are aware of this kind of testings. The major types we consider as analytical tests. Then comes material characterization, then comes material property test, and finally the product test. If we follow these 4 test types in our organization, then we can be sure that the quality of the final product that we are promising is being confirmed, and we are thorough. We are confident of our product. So, what analytical test includes? Now, analytical test includes very basic parameters like density, specific gravity, water absorption, moisture, sieve analysis for very fine powder or pulverized polymer, material characteristic or material characterization. Material characterization tests are used to identify the material, to determine the chemical composition, to determine the structure, to determine the flow behavior. So, and this material characterizations are most probably on the polymer part. They are not on the product part. So this test includes melt flow, viscosity, molecular weight and molecular weight determination, some spectroscopy test, thermal test, microscopy tests. So material properties, the material property tests are the major resource of selection of material. By this property test, we can select our raw material, we can select our inventory. So this test includes a wide range of testings like mechanical, electrical, thermal, weathering, chemical. Depending upon our product, we can use the test which are applicable for our product. And finally is the final finished product test. Whatever product we are manufacturing is finally tested, and that test is customized as per the products. There is no common test for all products. The tests are always customized, and it is according to their product. Number 1, according to their application. Number 2, the atmosphere where they are going to use. So these are all factors would be required to understand for having final product test. Now, testing is fine. But if I say that I have done the testing and it is showing some X result, and the same testing done by other person is showing some Y result for the same polymer or same material, then why such difference are there? It won't, this kind of difference will provide, say, not proper data and not confirm that whose product are quality, whose product is good in terms of quality. So, standards that we all know, same specifications are worldwide made for all the tests, so that we are all on the same platform where the testing we have to do. So standards and specifications helps to develop common language for developers, designers, fabricators, purchasers, and all end users. So what does standard mean? A standard is a technical document based on multiple results of science and technology experience approved by standardized body for the benefit of the people. Standardization. Now, it is an activity giving solution for a repetitive application to the problems, essentially in the sphere of science, technology, economics, aim to achieve the optimum degree of order at an given context. So standards, standardization, and finally the technical specification. It is again the document which lays down characteristic of the product or a service, such as level of quality, performance, safety, dimensions. What is required by our product is being specified in that technical specifications. So who are the bodies who make these standards, so that it is been spread throughout the globe? So these are the bodies which we all know, international organizations like ISO, basically all the plastic industries. This is a principal body producing standard, this ISO. For electrical application in plastic industry, IEC, International Electrochemical Commission, is the main body who was making standards. There are different national bodies, country national bodies like British Standards, BSI, American National Standard Institute, ANSI, American Society of Testing and Material, ASTM, DIN Standard, Dutch Institute for Norming, and Bureau of Indian Standard. We are all aware of these standards. These standards are the main backbone for the testing. So why, again, the aim to have these standards is to be on the same platform while testing. If I am testing as per ASTM and a person sitting in Germany is testing same product as per the same ASTM, then definitely our results, our test reports would be same, having same data. There won't be a difference in any kind of data. That is why the standard are very important. So now we will first go with some brief testing and what are the standards. Again, for example, these are some examples of mechanical testings with their standards. Say tensile strength is tested as per ISO 527 as well as ASTM, American Standard for Testing and Materials, 638. Flexural strength, ISO 178, ASTM 790, DIN Standard. Similarly, impact strength, hardness, compressive, abrasion resistance, all have got a specified standard, so that we all who are testing or who are having the reports can see that the product has been tested at same environment, same parameters, and same conditions, and the results which are obtained are authentic. These are some thermal test standards. Melt flow index, it is ASTM 1238, that has been used for plastic industry majorly for raw material granules. Heat destruction temperature, ISO 75, Ricard softening point, limit oxygen index, ISO. These all tests have their own application as per their product. So it is not necessary that we have to do all the testing, but it depends upon our product for which it is applicable. We have to follow this standard and we can do the testing. Now, for electrical and insulation industry, there are standard tests like volume and surface resistivity, which has got IEC, dielectric strength, breakdown voltage, again IEC. Basically, electrical testings are done or accepted by IEC standards rather than other ASTM or ISO. So now the main part where I am interested and my expertise is, apart from normal testing, is the investigation of unknown plastic part. This is the point where everybody would love to hear and would love to understand that what are the tests by which I can investigate my competitors' material, I can investigate the presence of different material, I can make my own composition having the support of my reference material. So here I'm going to have one case study. So this case study means if you want to investigate any of the part, then this test format has to be followed, which I would be suggesting or I would be briefing. So first aim, our aim is to identify the base polymer present in that plastic. Suppose if I will just show if I have got some sample. Suppose if I have got this charger and it is made of some plastic. I don't know which it is. So first test is to check which plastic it is, which is the base material of this plastic. Then second is to identify the presence of other polymers present in the plastic part or not. Suppose if I did work first test, I found out that it is an X material, then I have to check whether it is 100% with the same X material or it has got some other materials, other polymers also. So the second task is to identify the presence of other polymer or not. Now the third is to check whether my material has got inorganic fillers or any additives or any pigments or not. So that is the third part. And suppose if I can find that my material or my reference material has got some inorganic material, then which is that inorganic material? That is the fourth task, to identify the inorganic material present in the part, that is filler. So here we go. The first case study, how to identify the base polymer. So there are many techniques people do visually by doing, say, sink test, flammability test, smell test, fine. But since we at this stage when we are doing some R&D, we should have a very concrete test method to confirm the base material that we use. So the analysis is very well known, spectroscopy analysis. In that, Fourier transform infrared spectroscopy, that is ASTM E168 FTIR. This is the proven test method to identify the polymer, the base polymer. So FTIR analysis provides information about the molecular structure, the functional group present in the sample, and the chemical bonds sometimes by which they are been linked. The functional groups are been linked. But FTIR provides the data of the material which is present in maximum proportion. So the principle of FTIR is very simple. The infrared at the different wavelength are absorbed by the functional groups, and the variation frequencies are of the different molecules are different. So we can get a different peaks. I will show the FTIR peak, a reference sector peak, how it. So all these peaks have got different functional group, different bonds, different weightings, different, I think, so we can, so I will just show you one example so that it can be, this is a simple photograph of normal FTIR that we have. That can be different for everybody. It's a latest one, Diamond ATR. Yeah. So this is a reference FTIR which I'm showing. You can see there is a graph of transmission versus wavelength. Wavelength is the absorptions of infrared. Different functional group, different bonds, different sometimes say linkages have different wavelengths. So this FTIR method can provide us a knowledge of a base polymer. But again, I'm just repeating that it does not confirm that that material is 100% the same or not. FTIR will give you the data which has got maximum portion of the polymer present in that sample. So these are the just example. There are a number of frequency range, but just to have a brief that for hydroxyl group, we have got a frequency at 3850. It's a range, but this for ketones, it is 1733. For cyanohydral bond, that is 3. There's acrylonitrile, for example, ABS is very easy to evaluate. We get a peak at 2200. Then we have got, say, 3300 to 3400. It's for amines, that is ammonia, amine stretching. So these are the frequencies, and functional groups can be easily identified. So now, how to identify that my material has got 100% the same material or it doesn't have any other material or not? So the second test, which is the most important test, I say, is calorimeter analysis, differential calorimeter, DSC, ASTM D3418. I love this test a lot because it gives the complete magical data of the compound, of the sample, of the product. Means you cannot hide anything from this. No polymer can be hidden. They cannot be hide themselves by this test. So what is this test? DSC provides valuable information about the thermal behavior of materials, including the phase transition, heat capacity, thermal stability. We all know that all polymers are having different melting point. They behave differently at different temperature. So this is the machine, this is the device, this is the test method by which we can study, we can get the energy that has been consumed by that particular polymer at that particular temperature, that particular time. So this is a very beautiful data. You can use, mostly R&D people are using this data a lot. So it helps us to get the glass transition temperature, crystallization, melting points, purity, and heat capacity. I will just give you one example that nowadays, the electrical body, that is power grid, you would be knowing all. They were using thermoset material in insulations, in capacitors and all that thing. But they were facing lot of failures in the field. But nobody found what was the reason why such failures were obtained. So R&D researchers have investigated, even the industry has collaborated and find out that the issue that was faced was the glass transition temperature, the TG. The thermoset, means UP, polyesters or epoxy that were used were having TG of 100, 110. Again, that was accepted, that TG was accepted by industry only. Means they only told that we want this TG. But then they found that this TG, the range is very less. We need to have if we want to stop the failure, then we need to have TG above 125 or above 130 like that. So then they provide this challenge to the manufacturer, raw material manufacturer, that they want the material having capacity, having the TG higher than 130. And that is only accepted for this insulators that are used for the transformers or power grids. So DSC is the most important test for polymer industry that I told. And the principle is based on measuring the heat difference between the sample and the reference. Always there is a reference kept and we have to compare. Obvious, it is but obvious. How to do any test? It is comparison test. So here also DSC compares the heat flow between the sample and the reference. And what is the difference is been shown in a graphical manner. Yeah, this is the DSC machine that I have. This is my own picture, my DSC machine that I use. And it has got multiple ranges. For example, it can find glass transition temperature from -80 to +600. There are DSCs which is a good range for polymer industry, but there are other DSCs which can go up to 1600 for ceramic industry. So this is a simple graph that I educate everybody who comes to me that as much as many peaks you see in the DSC, consider that much material is present in the sample. Simple, very simple. Nothing to go much detail. For this DSC, you can see we have got two melting peaks. One is 123.3, another is at 218.1. But this does not tell that which material it is. But the test that I told earlier, that is FTIR, says that this material is polyethylene, but I don't know again which polyethylene. So I did DSC and found that it is an LLDP because it has got a melting at 123. Suppose if it was LDP, then we know that LDP melts at 90 to 100. We know that LLDP melts at 120 to 125. Suppose the melting point has increased and it is upon 130, then we will be find that it is HDP. Now the melting point at 218, which is that material? Again, since it is in very less proportion, FTI doesn't shows the presence of this material because there are many other organic and inorganic materials which will hinder the spectrum of FTIR. So we won't be able to get the peaks of this material, which is at 218. But again, by our own experience, we can very easily identify that this material is nylon, which is mixed with this LLDP in the sample. So now how to check the composition? I have found the base material is polyethylene, but by DSC, I confirmed that it is LLDP and also confirmed that it has got nylon mixed in that material. If I haven't done DSC and I have just confirmed on the basis of FTIR that my material is polyethylene, and if I would be using that material with that partial knowledge or partial testing done, using that material for the product, which supposed to have a temperature resistance of say 115 plus, so my product would be failed because I haven't done full testing of that product. And DSC, FTI runs side by side. FTI is means not complete without DSC. We cannot say that only FTI will justify our requirement. No. DSC is must. Now this third test, which I'm telling, it is not related to the two tests because it is not mandatory test. This is called thermogravimetry analysis. This is very simple test. What does it say? It measures the weight loss at particular temperature. Very simple. A sample is being placed in an instrument where it is heated at some particular fixed rate, say 10 degree or 20 degree per minute, and the weight loss, the reduction in weight is calculated and been recorded. So this test gives us the different material which has been evolved or which has been degraded during the whole process, like volatile material, say medium low volatile material or some combustible material, and finally whatever the material which is not being degraded, it means the residual mass or say filler content we say. So TG help us in the composition estimation of the polymer and the fillers. So the principle I have told already that it is measuring the mass loss versus temperature. So the last result which is obtained from TGA is the residual mass, which is the filler content, that we can also do with the normal muffle furnace process. If we just wanted to find filler content, we can also use muffle furnace process rather than doing this expensive test. But TGA, DSC, FTR, using these three combination, we can estimate the very important and rather say very challenging test is the composition of the material used. Now, composition means, suppose my computer has made a formulation which is, say, showing X property, which is not, means I am not getting that property. But by doing a detailed analysis of these three tests, that is DSC, FTR, and TGA, we can come very close to the formulations of that thing. We can have, I can very surely say that there would be an error, but that error would be only 10%. And that 10% can be rectified by fine-tuning our formulations. So these are the three tests very important for that kind of R&D at higher level where it has been required. Again, this is DSC machine, how it looks. And yeah, this is the this is TGA machine, not DSC, TGA machine. And this is the standard TGA graph where you can see on the y-axis that is weight and on the x-axis that is temperature. At 100%, we just start the machine, the temperature increases. As the graph comes down, there is a degradation of different gases, moisture, volatile material, different polymers, and lastly, what is stayed is ash, that is fillers or inorganic material that cannot be degraded at 800 or 2000 degrees temperature. Now, suppose I found that my product, that is this, I found the plastic which is used, I found the different polymers which are mixed in this product, and finally I found that it has contained 25% of residual mass, that is inorganic material, 25%, but I don't know which it is. So to analyze that 25% of inorganic material so that I can make this component, I can replicate this same product in India. Suppose this is exported from Germany. So for that analysis, there is, again, it is an excellent test. It is called Energy Dispersive Spectroscopy, ASTM E1508/12. So this test will provide you an elemental data of all the inorganic material present in that sample with percentage. For example, if this product has got calcium, I can find calcium. If this product has got zinc, lead, or it has got magnesium, I can find that all the presence of all this element in percentage wise. What is the percentage? Normally, all the flame retardant persons or the manufacturers are asking for me for doing this test and to quantify the presence of all the inorganic elements present in that thing, so that they can very easily make that similar recipe for the, suppose, V0 or V10 or UL90 or whatever the flame retardant additives they are making. So I will just read the principle, how it is. EDS provides detailed information about the elemental composition of a sample. It identifies the element present in their concentration and their distribution within the sample. EDS helps in the composition estimation of inorganic material, as I told. So what is the principle? It is very simple. It is based on excitation of characteristic X-rays from a sample and then measuring the number energy of these emitted X-rays to determine the elemental composition. It is highly sophisticated equipment, and it is been, this equipment is adjoined with another microscope equipment called scanning electron microscope. So I will just show the picture of both the equipment joined together. Yeah. So this is a scanning electron microscope. The first computer screen shows the scanning electron microscope, and the second screen, which is being shown, is the energy dispersive spectroscopy. It is not a machine. It is a software. It is analysis which which reads the data which is generated by scanning electron microscope. So these are the images, how it looks. It's a beautiful image of calcium carbonate itself, CaCO3. We can definitely find the particle size of calcium carbonate with this thing. And on the blue chart, which you can see, that is the energy dispersive spectroscopy. All the elements which are seen in the product are popping up in the graph, whether it is sodium, plumbum, lead, silicon, calcium, whatever it be. So finally, conclusion received from this 3-4 analysis is, number 1, we will find the base polymer by FTIR. Number 2, the presence of total quantity of polymer present in the apart from the base polymer with the help of DSC. Number 3, with the help of TGA, we can find the percentage of filler if present, as well as detailed investigation of the 3 can also brings us close to the recipe of that product. And finally, the identification of filler, that is by energy dispersive spectroscopy. So I think, I think what I wanted to deliver, I have delivered. And testing is very important part of production, manufacturing, even marketing people are right now behind the testing, that they are also uh, saying that we want this all test reports so that they can sell their product very easily. So I want that we should focus on testing and should be have a good quality product. Thank you.
So much, Dr. Vyas, for uncovering the hidden world of polymers and for guiding us through how advanced testing techniques reveal critical insights into their structures, performance, and reliability. We will now open the floor for questions. There are two questions in the question answer box. I will read them out. First one is whether DSC can identify the recycle percent present in the same family of polymers, plastics. Yeah, polymers and plastics.
I was
Can
expecting
I
this
read it
question.
again?
Yeah, no, I got it. I got it. I was expecting
Okay.
this question.
Yeah,
I was
okay, sir.
very
Okay,
well
sir.
expecting this question because this is a challenge that has been faced by the industry, because virgin polymer is mixed with recycled polymer, but how to quantify that thing? Yes, definitely, DSC helps us to confirm the presence of reprocessed material in the virgin material. Yes, it does. But again, it is not very simple that when we run DSC, suppose if we get this peak, it is for recycle and this peak is of virgin. No, because I will just give one example. Suppose a nylon 66 is mixed with another nylon, which is a reprocessed nylon. Both are similar. If it is one time reprocessed, then there will be different DSC and energy absorption. If it is two time reprocessed, there will be different. If it is three time reprocessed, there will be different. So I would like to say definitely this DSC helps to confirm the presence of recycle, as well as if we do detailed analysis by a couple of other some tests apart from DSC, we can definitely find there is chemical testing with DSC so that we can confirm the presence of reprocessed material present in the sample or the compound.
One more question is there. While developing strategies for plastic upcycling, challenges in identifying and separating different types of plastics due to insufficient or unclear labeling of the materials, what measures would you recommend to address this issue, and what responsibilities should be assumed to improve material traceability and recyclability?
This is recycling issue which are we facing. The first thing which I tell and which is very easy is to have basic civic sense for a domestic person who are using plastic, and for the industry person who are using this different plastics in their industry, they should have proper arrangement for placement of different plastics. They should have proper arrangement for placement of the rejected plastics. What happens? Why such issue arises? During the production, there won't be any issue. But when there is a rejection, or when there is something, say some materials are coming back due to rejections, at that time, they are the things who are giving a challenge to the industry that they are mixing. So there should be a proper way of handling both production as well as the reprocessed material or the rejections. If we do this in a proper way, and that has to be means organized. It is just organizing our wardrobe. How we are organizing our wardrobe. There are wardrobe which have got mix and match everywhere, or there is a proper wardrobe. So
Yeah, I think there are no more questions. Yeah. So, as we come to the close of today's session, I would like to take a moment to express our heartfelt gratitude on behalf of Plastindia International University. I sincerely thank Dr. Harindu Vyas for sharing your expertise apart from traditional testing, real life experiences, and inspiring ideas for a more sustainable future in plastics. Your work definitely encourages people in the industry as well as the teachers and the young minds. A special thanks to Dr. Prashant Gupta, Senior Assistant Professor, for setting the tone and enlightening us for PIU's mission in shaping the future of plastics, polymer engineering, AI, and sustainability. A special thanks to all our participants. Thank you for joining us for this fourth edition of Parivartan Webinar Series. We hope you found today's session enriching and engaging. So stay connected with us for future sessions as we continue to explore critical themes at the intersection of technology, environment, and innovation. Our next session will be by Professor Mathis Woluj, International Specialist, Anthem Bar, Grains, Australia. Make sure you register for the webinar and take advantage of this discussion. The link will be sent to you by email after the session. Thank you and goodbye, everyone.
Thank you.